Hi and welcome back. In lecture 24, you learned how to display text in an LCD screen. Although this was a simple way to show useful information to the user, the sheer number of wires required to make the LCD work makes the solution far from elegant. In this lecture, I'll show you a much improved solution to the same problem, one that involves a single data wire plus power. The difference is stark. Have a look at the before on the left and after on the right images for the exact same result. To achieve this reduction in total number of wires, we have to switch the type of interface we use to connect the screen to the Arduino. Natively, the screen uses a parallel interface where each of the 8 bits that make up a character encoding uses up a wire. You may remember that in lecture 24, we used a 4-bit parallel mode instead of the full 8 bits in order to save 4 wires. Still, even 4 wires are too many for transferring data. We also needed wires for power and for the screen backlit. To improve the design, we'll use an adapter that allows us to connect the parallel LCD screen to the Arduino using the I2C serial bus. We have used I2C before, but here's a quick recap. Use one wire for data, SDA, which goes to analog pin 4 on the Arduino Uno. Use one wire for clock, SCL, pin A5 on the Arduino Uno. Use one wire for 5 volts power and one for ground. This bus can also be shared among multiple I2C devices, which means that you can connect multiple compatible devices for your Arduino without increasing the wire count. The adapter I use in the demos is the 1602 LCD display I2C board, like the one in this image. It contains 2 rows of connectors. The long one that connects to the 16:2 LCD screen, and the short one that implements the I2C interface and connects to the Arduino. On the board, there's also a potentiometer that you can use to adjust the brightness of the screen, and a microcontroller that handles the conversion and communications workload. In Demo 1, I show you how to connect the 1602 LCD to the screen and the Arduino. In Demo 2, I will add a second I2C device to the circuit, a real-time clock, and show you how the same I2C wires can be used to drive both devices by displaying the time from the clock to the LCD screen. In this first demo, we'll have a look at the parallel to serial adapter using the I2C interface. This little device here is what's making it possible to go from parallel to serial. You may remember in lecture 24 when we connected this LCD screen directly in parallel mode into the Arduino, and we were using back then these digital pins to carry the data. We used 4 of the digital pins, so we used the 4-bit parallel mode. Still, there were too many pins to worry about. We also had to power the backlit of the LCD. Just too much wiring to worry about. So, in this demo, I'm going to show you how to connect this little device in order to simplify the wiring situation and to be a bit more efficient with how we use the resources of the Arduino. So what we've got in this device is 2 rows of pins. This long row of pin corresponds directly to the pins of the LCD screen, so 1 to 1. And then on the other side, we've got the implementation of the I2C interface. We've got the ground and V5 volts pins, and then we've got the SDA. SDA stands for data, and SCL, CL stands for clock. So the only 2 pins that we need in order to transfer the data, SDA, and the clock signal synchronization between the master device, the Arduino, and the slave device, the adapter. Wiring is very, very simple, so let's go ahead and do that. I'm going to plug the adapter here and the LCDs and the LCD screen here, so that there is a nice one-to-one correspondence between these 2 pins. Oh, by the way, when you receive the adapter from eBay, it will not have a headers on, so you're going to have to solder this and that row of headers. Then I also use this wire, jumper wire, just keeps my wiring tidy. Plug that in here. So now I've got ground signal using the blue wire, VCC, the brown wire, SDF for data is yellow, and clock is the white. Next I'm going to connect the data pin, so the white wire, and that is going to analog pin 4 on the Arduino Uno. And then the yellow one, white is the clock, should go to analog pin 5, and on the Arduino Uno, data goes to analog pin 4. I'll show you what you need to do in case you don't have an Arduino Uno and you've got another variation of the Arduino. Then red goes to 5 volts and black goes to ground. Okay, done. Let's connect, run the sketch, make sure it works, and then I'll give you some background on the RX2 interface. Well, it looks like it is working because I've previously loaded the sketch, but let's have a look at it. Let's verify first of all that it works. Okay, hello world, row number 2. Let's have a quick look at what's inside this sketch. We start by including the wire library, which implements the I2C interface and its protocol and functions. Then we need the LCD library and the liquid crystal underscore I2C library, which basically this library, the liquid crystal underscore I2C, extends what's inside LCD and in some cases overrides some of its functions so that we can use familiar functions like you can see down here, lcd.setCursor from back in lecture 24, exactly the same function and structure with its parameters as back then, but this time all the data, all the information that the screen displays travels through the yellow wire. Now the new thing is, how do we initialize and instantiate the object LCD? So that happens here. You see we've got a class called liquid crystal underscore I2C. We give it a name LCD, and then we'll pass a bunch of parameters in order to initialize this this new object that we use down in the setup function. I'm going to show you in a few seconds what these parameters mean. Let's move on with the setup function, and just like we saw in lecture 24 with just a parallel connection between the LCD and the Arduino, we use the begin function and pass the dimensions of the screen that we're going to use, so 16 columns and 2 rows. Turn the backlight on, set the cursor to the very beginning top left corner of the screen, and just print out a bit of text. Then move the cursor to the next line, so column 0, line 1, and print out a bit of text, and so on. So this is very, very familiar syntax. Let's have a look at this library. You can get this library from Bitbucket. You can download it. Okay, there's a link here from where you can download it and install it, as we always do, into the libraries folder of your IDE, and this is the folder that contains all the necessary classes and header files. The one that I want to show you is this one here, the one that we called in order to use our LCD screen via I2C. If we go inside this file, scroll down a little bit, you'll see the constructors. So there's several constructors. Now which one you use depends on the hardware that you have the LCD screen and the adapter. So this class can be used with different kinds of hardware. The one that I found that works with my hardware configuration is this one here. You can see that the first argument, the first parameter, is the address of this I2C device. So because I2C is a bus that can be shared between multiple devices at the same time using the same wire, when the Arduino sends data to one of its devices, it needs to provide an address. So the address indicates which device is supposed to receive the message from the Arduino. So in this case, this device has got an address, and you can look at the demo sketch, and you'll see that the address that we are passing is this. So it's 27. Now this device can be given alternate addresses in case you have, for example, multiple LCD screens that you want to use via the same I2C interface. You can see these little pads here. If you bridge those pads, you effectively change the address that this device will be listening to. We've got 3 pads that you can, 6 pads that you can use to create up to 3 bridges. So that gives us a total of 7 possible addresses that this device can have. In the next demo, I'll show you how we can use 2 devices, 2 I2C devices on the same bus, and because they each have their own unique address, there is no conflict. So that's what the first parameter is about. Next, we've got the definition of various pins. So the enable pin, that's for the LCD. Okay, it's explained here. We've got the read-write pin, again for the LCD. The reset pin, again for the LCD, and then the backlit pin, again for the LCD. So these parameters define the roles of these pins here, the pins that correspond to the LCD device that you use. So if it happens that your LCD device is different to mine, you look at the schematics and the data sheet for the LCD, and you can vary the configuration of your constructor by just adjusting the numberings of those pins. You can look down here, this one here actually. This constructor uses the 4-bit parallel mode of this LCD screen, so you can see that it also defines the 4 data pins on the LCD screen. So this actually corresponds to the construct that we used back in lecture 24. So again, having another quick look at my example, you can see that these parameters correspond to the data pins. So we've got 4, 5, 6, and 7 data pins that correspond to the LCD screen. Finally, pin number 3, which is let's see, this one here on the LCD screen. So V0 it's called on the PCB of the LCD, controls the backlit. Just saying that the backlit turns on when this pin goes high, so positive voltage. Okay, so don't be afraid to have a look inside the actual source code of these libraries to see how they work. Usually they're very well documented with very useful comments, so you can figure out if you need to make any changes at all to the code that I'm showing you here. Lastly, what I want to show you is that the Arduino website contains information about the wire library that this serial to parallel adapter is using. And just in case you don't have an Arduino Uno but you've got some other type of Arduino, just consult this little table to tell you which pins you should use for data and for clock. So you can see here that for the Uno, and in case you've got an Ethernet shield hooked onto your Arduino, then A4 and A5 are the pins you need to use, the analog row. If you have a Mega, then you're looking for pins 20 and 21 and so on.